Hey Phobos, how's it going? Alright, cool. Live. I want to mix up the music today, but like this already just is not it. Um, you know what? This might be a good one. No clue though. Okay. Public domain kids songs? Is that like the actual name of a group, or like at least the owner of the music? Or are you saying like public domain songs in general? Oh wait, oh kids, oh I completely misinterpreted that sentence. Jeez. Public, yeah, kids songs that are public domain. Like public domain kids, is that like dude, I'm not mentally with it today, I think. It's a nice sounding it is. Yeah, it sounds like a real like it's not so like a band, but like like the type of like name of a group that would like buy songs so people can play it publicly on streams, like that one person whose name I can't remember. An indie group, yeah. Like the stream beats person. Um all right. I don't think we have any questions that are like held over from the last time I streamed. So we'll start off with, I guess, some studying. Or if Jed gets here, maybe we'll look for questions on the internet. But I should probably do algebra right now. I don't think I'm going to be particularly successful at either, because I'm not feeling super with it right now, but we're going to try. So there's a question, it was 25. The last time I tried 25, I just was not getting it. And Penson was even giving me hints, and I still couldn't figure it out, because dihedral groups are just so dang weird. So D is a positive integer that is not 2. D divides n. Show the number of elements of order D in D sub n is phi of D. So I was thinking, with dihedral groups, all the flips are always order 2. What is phi of 2? It's 1. Less than n and relatively prime 2n. Oh, this is one of those weird things where 1 is relatively prime to 2. Yeah. Okay, yeah. That's why 3 is 2. Okay. And if it's an even-sided shape, you have one self-inverse rotate R180. So, I mean, I guess I've already answered that part of the question, which is I mean, I guess we could probably make it like a function of n if we really cared to, I guess. But if it's an even number, it'll be half the order plus 1. If it's an odd number, it'll be just half. Or an odd-sided shape, I guess. Which, yeah, that'll be like d sub 5 is a pentagon, which is order 10. So yeah, if it's... the order is always even, but if n is even or odd. But that's not really the biggest question of this. This is, Hey, Nail. Yeah, I remember you. Welcome in. Hey, Padraig. Nothing much. How about you? Embode, hello? How's it going? Right now I'm working on 25. I'm doing good too. Thanks for asking. Oh, did you post a question? Oh, geez. You're painting your room right now doing this Spider-Man style? It's hard. It sounds hard. Padraig, yeah, so we might be about to switch gears to a problem that someone just posted, but d sub n, if it's like d sub 4, it's a four-sided shape of square, which is order 8. So yeah, 2n elements. I assume that's you who posted a code, because I just can't see the full usernames in Discord, but so I feel like I generally can't do your problems, but let's at least take a look at it. That wasn't you? Oh. Okay, I don't know. I forget. I feel like I've seen that person's... I don't know what their Twitch name is, but this person, I usually can't do their problems, I feel like. If it's the person who I'm thinking, at least, I can only see the first like letter in the avatar. All right, Neil, well, thanks for saying hi. Good luck with the painting. This isn't very... Screen's just a little bit too wide. Let me see if I can figure out a way to scale it up. Oh, jeez. Well, it's scaled up. What? Where did it go? I can't find it. Wait. Reset transform. Okay. This is a finicky beast right here. Okay, there. Yeah, exactly, Phobos. All right, hopefully that's a bit more legible on stream. ABC being an acute triangle with altitudes A, D, B, E, C, F. That will be the center of its circumcircle. Just is not easy. Sorry, I'm looking at the other question they posted too. Um, just let me make sure I know. Like triangles with so many weird, or there's like a million definitions with triangles. So altitudes are perpendicular to the opposite side. Okay. And all the altitudes form an orthocenter. Um, I'll be honest, I just don't think I can do this. It looks like a competition problem to me. I'm just gonna go back to doing the algebra and say hear back from this person because I don't think I can do either of their problems. um, hey, SPQ. So I'm gonna go back just looking at 25 for now and thinking about that. So the thing that Penton was giving me for this is to remember that subgroups are also groups themselves. Both they're in the math discussion channel in my Discord. So you're welcome to try them for yourself, but I doubt I'll be able to do them. So. Page group? Yeah, I agree, SPQ. I feel like I should get used to working with these, at least for the sake of getting through this book. But it's so like, so I've noticed that just the rotations is a cyclic subgroup. If you take the smallest rotation, that's not R0, or the biggest rotation, those both always generate the all the other rotations. And if you're given an odd-sided shape, I think all of them generate all the rotations. Like they're all generators. I need to look back up at some of the theorems up here, I guess. Hey, $10. Math is life. It can be. How do you make a matrix in LaTeX? That's a good question. Let me see if my cheat sheet has it. Oh yeah. I guess. Like, how do the actual like entries go? Interesting. Let me see. I have like a LaTeX cheat sheet that comes with the frickin' bot in Discord. I don't think the cheat sheet includes matrices though. Yeah, I don't see it on here. Annoyingly. Oh, okay, so you really just the usual slash, is it? Interesting. Okay. So for 25, I assume we want to consider the subgroup of D sub n. Just start writing things, I guess. Oh, thanks for getting that like link. Like, what do we define a subgroup R, which is all D in D sub n such that D is equal to R sub 360 over I just want to subgroup that as all rotations, I guess. And trying to do it with that notation is confusing me. Consider the subgroup. Call it R. R is cyclic because I guess I think we should prove that R is a subgroup, but I'm just gonna not. R is generated by 360 over N. For all N that D sub N is valid. I guess what do we know about like if I take I assume that if I look at this subgroup and get the order of each element, it's going to be the same as the order of the element in the entire group because of closure. Do we actually have something that says that though? Like I want to work within this cyclic subgroup to figure out the orders of things. Ah! Dang it. I was doing so well with my flipping. If N is even, R sub N contains one element of order 2, R sub 180. Wait, that actually messes up the application. Is this not a cyclic subgroup or why? I wanted to just say this is a cyclic group and apply theorem 4.4. I haven't learned about isomorphisms yet, Padraig. That's kind of like the issue, I guess. Really, there probably is an easier way to prove this, but I guess doing it with the tools that the book's provided so far. is the thing. If D is a positive divisor of n, the number of elements of order D in a cyclic group of order n. Oh wait, so this actually does fit with 4.4. See, I want to use this thing on the cyclic subgroup that I just created. I was debating that R sub 180 seems like it might, I thought it might mess things up, but this actually seems like it doesn't mess things up. You solve both problems? Oh, well, thank you, Bode. I appreciate that. Yeah, well, I think they defined it for n greater or equal to 3. I hope so. Let's take a look at that, though. Because n equals 2, wouldn't that just be a line? I don't know how that would work. I guess you could, there'd be one flip and one in 2 rotations or something. Where do they define generally the dihedral group? Yeah, I definitely do not like. Oh, okay. I guess it. Um, I am pretty terrible at working with the dihedral groups. The book kind of makes you figure out a lot of things about it on your own, which I guess is fair, but oh, they literally say this is a cyclic rotation group of order n. I just want to see if they define it for. I assume it's n greater than or equal to 3. Yeah, okay, so we don't have to worry about n equals 2. Is there a Tugon? Like, just like geometry? I feel like there wouldn't be. The number of elements of order D Cheese, aka Thunder, hey. You can't think about D sub n any other way? Let's see. The dihedral group D sub n has the group presentation D sub n equals alpha beta, alpha to the n equals beta squared equals E. Okay, so your alphas are your rotations. Your betas are your flips. Beta alpha beta equals alpha inverse. If you flip something, rotate it and flip it back, that's the inverse, really? Yeah, I mean, I guess I don't know what a presentation is, but I think I can kind of like piece together this is saying at least. The semi-direct product of C2 and Cn? Oh gosh. Hmm. Um, do you have the mechanics dot product type question test tomorrow? Oh no. Well, good luck, Thunder. Cheese. Ugh. So are you almost on like on break then, or? Christian FRFR, thanks for the follow. Basically, generators relation. You can for sequences from the generators. Form sequences from the generators and remove the relations. Okay. You have like important exams day and after a month, then you're on break. Okay. God, you still have a ways to go then. So wait, so are like for 25, I already made a cyclic group, so doesn't that mostly answer the question for us? And I would think that an element in a subgroup has the same order as in the entire group. Talos, hey, how's it going? Talosophin? Just breaking my brain on some abstract algebra right now. Number of elements of order D in D sub n. Oh god, dude, I can't write. Hmm. Just the phrasing of this. So there, I guess like the order of this subgroup is half the order of the entire dihedral group. Does that matter? Like, do we have to account for that? The number, oh my god, okay, let's just go back to the thinking chair. The number of elements of order D in D sub n is phi of D. So this is for each divisor of n our D is. But the subgroup I made is n over 2 order. Or wait, well, no. It's order n because the order of D sub n is 2n. D is a divisor of 2n. Well, D divides n. No, this is... Oh, okay. Oh my gosh. Okay. The number... So, I feel like this is doing the work for us. I just, like, I'm trying to... I'm gonna look at what the book says the answer is. Also, tell us that emote is kind of amazing. Is it new? I don't think I've seen it. D is a positive integer, D is not 2, and D divides n. The number of elements of order D in D sub n is phi of D. Okay, so of order D in R is phi of D. And maybe the next step of the argument is to say that the order of each element in R is the same as the order of each element in D sub n. And that would be the proof. It's like, I just want to, it doesn't feel like very proofy, but I just want to say by the closure of R. Element is the same as the order of each element of each rotation in D sub n. All flips in D sub n are order 2. Okay, I'm going to say that's my proof, and I'm going to look at the answer in the book. Hey, SG1. Oh yeah, this book has been using E for the identity. Order in a subgroup isn't really a thing, Padraig? I mean, the subgroup still contains the identity, right? And in inverses, so I feel like you could talk about it. I don't know. I'm gonna look at the answer, I guess. This is 25, chapter 4. I feel like 545. That's not bad. Nope. Let's try 580. Nope. I think we're close, so I recognize this page. 590? Overshot. There we go. Of course, they have a 3-sentence proof here. All right, so it's this right here. Zoom in a bit more. Okay, so it's that one. For the first part, apply theorem 4.3 to the subgroup of rotations. Wait, I said theorem 4.4. Did I might have misremembered what number it was. We should look at theorem 4.3 to make sure it's the one that I'm thinking of. Really? It is just... Okay, that's the entire proof right there. 4.3 to the subgroup of rotations. What page was I on? 110. But we need to see what theorem 4.3 is. Oh. If the order... .3. Yeah, the book has made typos before. If the order of the subgroup generated, or the group generated by A is n, the order of any subgroup of A is a divisor of n. Yeah. They must have meant 4.4, I think. So I feel like I've had the idea of this problem then for a while. I just didn't feel like that was enough to say it's a proof, I guess. So maybe it just speaks to my discomfort with algebra in general, in the dihedral groups especially. Let's go at what Penzenter assigned next. Wait. Oh, no, never mind. I'm looking at the wrong thing. 30. Right here. I can zoom in one more time, I think. Okay, 30. Suppose G is a group with more than one element. The only subgroups of G are E and G. Wait, what? Oh, okay, never mind. Okay, so this intuitively makes sense, where a cyclic group is generated by a single element. So if G is cyclic, then, and I know this is the backwards direction. If G is cyclic, well, okay, and has prime order, yeah. Yeah, if G is cyclic, then whatchamacallit. By closure, or you're gonna run into issues with closure if this thing wasn't true, right? I think. The only subgroups of G are E and G. Prove that G is cyclic and has prime order. So this is an awkward proof for me to approach because I think it'd be pretty easy to prove the reverse direction, like just with theorem 4.3 or something. If G is cyclic and has prime order, its only things are this. Or its only subgroups are those two. But we're trying to prove this order, and I feel like we have less to chew on. And I don't see how a proof by contradiction, I don't think it gives us much more to chew on, I feel like. Like much more to like start with. The only subgroups of G are E and G. Do we have a theorem about, I don't think we have a theorem about like most all the theorems we have are for cyclic groups, and we don't have that it's a cyclic group yet. We have to prove that. This one is for groups in general, but I don't think it's going to be helpful. Hmm. But A, B in order, okay, this one might be helpful. Element of order n in a group. Maybe it won't be. Well, Yeah, I'm just going through what a proof by contradiction might look. I'm kind of coming back around to thinking it'd be a good idea. So proof by contradiction, we would start with the statement, if the only subgroups of G are E and G. Oh, no one got first, wow. Well, congrats, Jim. Prove that G is not cyclic or does not have prime order. All right, I think that's how you would De Morgan's that. So I guess we have to disprove, we'd have to show a contradiction with each of the parts of the OR. So that shows a contradiction with the cyclic part and a contradiction with the prime part, prime order part. Assume. Oh, I guess the prime part would follow from it being cyclic. Yeah. Well, I feel like maybe we're gonna need both of them at the same time, I guess, because you could absolutely, well, Hey, Nimbus. What subgroups of G are E and G? Prove that G is not cyclic. Or, then G is not cyclic. How do we, if I just boil it down to that, how would that work? Maybe let's start writing. And Jed, if you're going to be around, I don't mind taking a look through Reddit or something for some questions, but it's going to be lurking anyway. I'm going to keep doing the algebra. So, assume that G has only E and G as subgroups. And is not cyclic. So we're going to focus first on that part. I don't know, because I guess I want to do what people like want to watch, or I don't know, because I don't know. You said before you wanted to like look through some more questions, so I guess if you're going to be around, then I would do it. Otherwise, I just kind of will keep on doing the studying thing, I think. But I'm going to try and hopefully get through this question first anyway, so and then I can go and take a look. So if it's not cyclic, so if I kind of have part of an idea, which is like, can we consider like A belongs to, or I guess like small g. Oh no, consider A belongs to G. And actually, no, consider A belongs to G. There must be a G belongs to G such that G is not in the group generated by A if G is not cyclic. I think that's where I'm going with this, that this other G can't exist. What would I do here though? Would I... Oh, okay. Oh yeah, but that means how... Okay, okay. However, A is then... Oh shoot. A belongs to G and A is not E, we should say, I guess. However, if G is not in A, then A is a proper subgroup of G. Which contradicts the first part of the assumption. Okay, there we go. So now we have that, we have shown that G is cyclic. For the prime part of the proof, by theorem 4.3, G has a proper subgroup, I guess we'll say. Or I mean, no, just as the subgroup. For each divisor. Did they say it's order n? Okay, for each divisor of its order. Since the only subgroups of G are E, order 1, and itself, the order of G, must be prime. Okay. It's my proof and I'm sticking to it. Circum can be simplified. Assume G is not cyclic. And oh. Yeah, you're right. That's a simpler argument. It's like I was about to start talking about the subgroup generated by G, but then I was like, well, what's the point of that? Right? You know, it's getting like a little bit weird, and that's why, because that's just a simpler way to prove it. All right. Let's take a little look through Reddit at least and see if we can find just like a regular homework question. If we can't, then we can't. But since Jedras are requesting that we try this against sometime, I want to at least give it a little try here. I honestly, a lot of these have answers on them though. No, I'm okay. It looks like this one might be interesting, but I don't want to dig through all those symbols right now. How many non-congruent triangles can be formed? Either 3 or 44? So you make what, a right triangle and one of the flat faces. You can make another right triangle from corner to corner. I don't see what the third one would be, to be honest. I don't see how it would be 44. It seems like their thing for 44 is specifically counting congruent triangles, but like for different vertices, like. Oh yeah, I think so, Jed. If it's going to be a square in that case, right? So whichever diagonal you draw, it's the same or it's the same length, right? But you discovered something new. Check online, Euler. I've heard that said about Gauss, that when we try to prove something in number theory, and you think you found something new, there's a good chance that Gauss already did it. By non-congruent, I think congruent usually means all angles and all sides are the same. The entire shape can be rotated, but they would still be congruent. I guess rotated or flipped. Oh, I do see a third one now, yeah. You would take the diagonal of one face and connect it to a different face, I guess. Formed by the composition of a scaled orthogonal transformation in translation. Pick all possible unique combinations. Guys, can we defeat their 44 answer? I'm not really sure. I think that they're talking about like per vertex, like you have 3 non-congruent triangles you can make with each vertex individually, I guess. But I feel like I don't think we care what vertex we start from. Well, we gotta draw these out. The first case, that's the easiest one to see, is 1 root 2 there. We have the second case of a diagonal on this face. A sub B flat. Wait, what did I even just draw? Oh yeah, that's 3 diagonals on flat faces, I guess. That's an equilateral triangle? I didn't even think of this one. Huh. So your question about congruence made sense. There are a limited number of side lengths. Yeah, Jed, I think that's a good way of thinking about it, where our only options for side lengths are 1, root 2, and like root 3 or whatever the third one is. So that'd be like 1, root 2, or is that root 2? Then what's the big diagonal? I guess Pythagorean theorem on this, that is root 3, I think. I think you can make one with every combination. You can't make a 1, 1, 1. It's not as simple as like 3 factorial, I guess. Or not, I guess 3 cubed. It's not as simple as 3 cubed, rather, for permutation. Yeah, I agree, Jed. True, but I didn't think of thought we could do root 2, root 2, root 2, which I did kind of by accident. I don't think 3 to 3 would contain duplicates. It would contain things that are geometrically invalid. Or wait, or you're right, it's probably 3 times 3. Okay. So it might be better to start with you basically have three choices to make. If your first choice is square root 3, we can only make one triangle, one like unique triangle, if we start with the root 3 side. If we start with the root 2 side, we can make I'm coming back around to hey. There's only one more triangle that we can make with root, or I guess two more. We can have all root 2s or root 2 and 1, 1. I don't know. Now I only see 3 again. Yeah, if you start with the side length of 1, yeah. Or that's the only you can make with two things of length 1. But I feel like I've drawn the 3 possibilities on the board. I thought I had another one in my head. But I don't actually see any other possible triangles. Um, uh, 24 plus 8 is 32. The third case, I think there's only 4 for the third case. Mm. Oh. Well, yeah, I guess there are more than four. Well, every edge could be the one length. Oh, maybe I see that. No, not an edge that has nothing to do with the diagonal. It has to share a vertex with the root 3. I'd say there's only 6. Well, okay. And there are 2 possible diagonals, so okay, that's where you get 12 total. Okay, okay. But now we're just counting duplicates. I don't think it's that. And I think that person is making the same argument. Like, they're saying those would be congruent. I don't think it's right in either case, because that's just duplicates. I don't like that, to be honest. Just feeling too lazy to work through that. I hardly know number theory syntax error. Yeah, sorry. Someone like Eats the 2 or Zach or like Ian Stuckey probably know more, or Bode and Shav there. Uh, Today for me is Thursday, so I will be playing Outer Wilds in like less than 24 hours. Spetri. Like my next stream would be Outer Wilds, I guess. It's 5? What other triangles can you make? Like, what are the other side lengths that you could use? All right, thank you, Spetri. You're gonna draw it? Okay, sounds good. Well, yeah, Jed, the reason I don't like it is that I've also had like 3-hour-long streams where I don't find a single question that I can actually answer. So that's why I don't like doing this anymore. I mean, I still like the idea of this. It's just the reality is annoying. But like, I do also like feel bad that like it's a part of the stream that you liked and I don't really do it anymore. So it'd be nice to like find a balance, but I'm just not really willing to rely only on this type of stuff for my stream anymore. So I'll spend like I guess maybe I want to spend some time looking through these forums for questions, but I just don't enjoy it being the main part of my stream. Um, all right, let's try. Actually, is there anything else? Like, I don't know. I bookmarked this a long time ago. I don't think I've actually looked through it though. This is like asking more for like advice, though. I guess there aren't too many questions here. Also, I imagine these forums are going to dry up even more over summer. I think they did the last time anyway. But as my, I'm gonna, I think give Reddit a rest. So I'm gonna keep this tab open because I may need to make a correction once we see what VOD has to say on this cube problem. But in the meantime, I think I'm gonna go back to the algebra. The next one will also be 34. A finite group is the union of proper subgroups if and only if the group is not cyclic. I remember seeing Penn Center do this one. And I think it's the one where I figured out the idea pretty quick. I have to remember what that is, though. Actually, is this the question I'm thinking of? What will be next? 41 or 44? I just want to see if I'm on the wrong track already. Oh, maybe I'm thinking of a different one. I don't know. A finite group is the union of proper subgroups if and only if the group is not cyclic. Right, I remember the idea. If the group is cyclic, and it is the union of proper subgroups, one of those subgroups must include the generator, and the subgroup that includes the generator must include every power of that generator, and which means it's the entire group and it's cyclic. And that one subgroup wouldn't be proper anymore, rather it's a contradiction. Assume that G is cyclic and is the union of proper subgroups. Well, okay. Let's be clear about, I guess, which direction of proof we're doing. Assume that G is cyclic, or assume, yeah, no, let's just assume that G is cyclic. 6 is cyclic. If G is the union of proper subgroups, then one of those subgroups must contain G's generator A. But this subgroup must also contain the group generated by A. Since G equals A, this cannot be a proper subgroup. Subgroup. Okay. So that's, I guess, the reverse direction here. I think you just drew the cube bed? Okay, no worries, bud. Okay, so we need to do the reverse direction. I think it's basically the same argument, though. G cannot be cyclic. One subgroup would have to contain G's generator. It's basically proof by contradiction without actually making the assumption, I guess. Okay, but I'm pretty sure that's the idea anyway, so I'm just gonna take that and run. So that was 34, so 41 is next. Ow. Just ran over my foot with my chair. Okay, 41. Let A belong to a group and let the order of A be 100. Find the order of A to the 98 and A to the 70. Huh. I'm pretty sure the order of A to the 98 is the same as the order of A squared, which is the GCD of 98 into 100. And the order of A squared should be 50, half of 100. And A to the 70 and 10 have a GCD of 10. So A to the 70 is like A to the 10, and the order of A to the 10 is just 10. I'm gonna check the back of the book though on this one. What page did I say, like 590? $50, 104? What? How's it bigger? Is that a typo? That has to be a type over 10, right? Maybe I'm going to Google the problem. Because there's no way A to the 70 has a bigger order than A. Okay, yeah, this person agrees. That must be a typo. Or, you know, I see a single Stack Exchange post, and I take it as true because it agrees with the answer that I said. 41, or 44. Which of the following could be the exact number of elements of order 21 in a group? I guess we need to figure out what phi of 21 is, and figure out which one of these is a multiple of that. So the number of prime numbers, or no, the number of numbers that are relatively prime to 21 and less than 21 is the definition of phi of d. Yeah, relatively prime. Or phi of n. It's probably easier to count what does go into 21 and subtract it off. 44. So we start with 21 numbers, right? 1 through 20. Is that 21 numbers or 20? It's 20, sorry. We start with 20. We would subtract out 3, 7. Oh, it's gonna be, okay, no. 3, 6, 9, 12, 15, 18. And then we'd subtract out 7 and 14. So we get 12? Which one is the multiple of 12? And that's a job for Wolfram. For 12, that's 1800. So I assume it's that one, but well, I guess we need to consider each of these individually. Well, I mean, none of these other two are going to be multiples of 12 then, right? Right, okay. So just 21,600. $47. Prove that C star, the group of non-zero complex numbers under multiplication, has got the phi of n elements of order n. Is C star cyclic? Is that the task here? What number could you multiply with itself to generate C star? Like, I assume it's gonna be something like 1 plus I or 1 minus I. Like, would we just try it and see if we can make the case that one of them generates C star? Well, isn't C star infinite? Wait. Does this not require a finite group? In a finite group, this is an infinite cyclic group. How would theorem 4.4 apply to integers under addition? Hey, Griffo the creator, you need help? Yeah, sure, what with? If you want, you can type out the problem there in chat or put it in my Discord. Whatever is easier for you. Yeah, sure. Go ahead. Oh. Prove that a squared plus b plus c, b squared plus can't all be squares at the same time. Um, that seems like one of those competition type problems, and I'm not sure that I'll be able to figure this one out. It, okay, I'm glad that you're still around, Bode. Channel my number theory training to solve it. Uh, their sum is a plus b plus c squared, if that helps. Maybe. I didn't think about summing them. It really factors like that? You sum them all up, you'll get a squared plus 2a plus b squared plus 2b plus c squared plus 2c. Yeah, I don't think that can be true, Fembox. If you multiply it back out the other way, I guess. Okay. It's an interesting thought, though. Some old-fashioned inequalities. I mean, my only thought for how to start is to let a squared plus b plus c be a square and show some kind of contradiction with one or both of the other two for why they can't be a square. I guess we'd assume they're all three squares and show a contradiction. Hmm. B plus c is greater than or equals to 2a plus 1. What if... Oh... Well... And these can't all be simultaneously true, is your argument, Bode? I don't remember even justifying that, though, I guess. They're all true? Okay. Oh, I guess, yeah, you haven't made any, like, Okay, yeah, that's fair. Yeah, I'm just kind of, like, wondering with your... If A, B, and C are any combination of natural numbers, like, with that statement there, what if you took B and C both to be 1? Then this inequality isn't like you. Most choices of A would make this inequality not true. Well, maybe B and C both being 1 is wrong for a different reason. A plus 1 squared is a small square larger than A squared. Okay, but like if A equals 4, B equals C equals 1, does this check out? 4 squared plus 1 greater than or equal to 4 plus 1 squared. No, that's 17 is greater than 25, right? Okay, and this is a new train of thought you've been typing in, I assume. Okay, so you're letting A squared plus B plus C be a square. It does have to be bigger than A squared. Yeah, I can see that. A squared is greater than or equal to A plus 1. Okay, yeah, fair. For what you've typed most recently, I think I'm on board with everything that you've written so far. Hmm. I'm trying to figure out where we would go from here, though. I'm still not really sure, I guess. Um, A plus B plus C squared is equal to K squared for some K. C squared, or C squared plus B plus C is greater than C squared. Plus A, okay, yeah, that makes more sense, yeah. C squared plus B plus A is greater than C squared. So K squared is greater than C squared. Okay, yeah, so K squared is greater than or equal to C plus 1 squared. So A plus B plus C squared is greater than or equal to C plus 1 squared. I'm still not sure about A plus B plus C squared being greater than or equal to C plus 1 squared. I feel like isn't that making the same mistake? I guess it's true if we're taking that to be a perfect square. We can't jump straight to that A plus B plus C squared being greater than or equal to C plus 1 squared. But if we know that, okay, yeah. Okay, yeah, that, I see that now, Bode, yeah. You're right. Doing this to the 3, you get B plus C. Oh yeah, so, okay. You can do it to all three of them, and some of them you get 2A plus B plus C is equal to 2A plus B plus C plus 3. But wouldn't it be greater than or equal to? Oh, and you said it's an inequality. Okay, yeah. Huh. Yeah, and that certainly can't be true for natural numbers. All right, so Griffo, I'm not sure if you're still here, but I think Bode found the answer, which, thank you, Bode. Oh, well, thanks for the follow, Griffo. I guess you are here, so, or if you already understand what Bode just said, then I'll just leave it there, but if you have any questions, please let us know, I guess. Thank you for that, Bode. And if you're interested in more math streamers, Griffo, you don't have to do anything you don't want to do, but whenever there's new faces around, I like to give a shout out to other math streamers out there who I can recommend highly. So there's a whole bunch of people if you want them. No worries. So yeah, I'm not too good at those types of questions, but thankfully there's people around in chat who are better often. Yeah, I agree, Bode. It's just I feel a little bit weird about like adding people to it because it's very nebulous, like what this group of people in the chat's command even are, I guess. But I agree that Hopeless is awesome, and I want it to be easier to like get everyone's links in one spot. So maybe it's something I need to like bring up. So I just did 44, I think. 47. Okay. Oh, that's right. I was thinking about C star being cyclic, apparently, under multiplication. So I guess let's just try things that I think are likely candidates for generators if it is cyclic and seeing if they happen to be generators. Because otherwise I don't know how this thing is possibly true if there isn't a generator. So I think, to me, the most obvious thing to try first is 1 plus I. So if we need to include every possible complex number besides 0. So every purely real and purely imaginary number, positive and negative in their combinations. There's no way, right? Like, 1 plus I squared is 1 plus 2I minus 1 equals 2I. 2I times 1 plus I is equal to minus 2 plus 2I. Minus 2, like, I could see this maybe generating it, but it's like, I don't know how you'd really show that it covers every single number. You know, this is just a conjugate but scaled. What is this going to come out to be? says 0. Oh. Well, that's not a generator then. Wait, what? This can't be right. Oh, it's -4. There we go. Duh. I thought they both canceled for some reason. I don't know, these are... maybe it can hit every number. I don't really know. It's not really obvious to me in the way that I was hoping it would be. But I guess there's even the question of, like, what is it? C star is infinite. Like, what is phi of infinity? I guess it's still infinity? Well, okay, so all the elements in C star are either order 1 if it's 1, or order infinity otherwise, right? And there's an infinite number of numbers that are relatively prime to infinity? Is that the... This is just a weird question to me. I don't think I'm going down the right... I'm gonna look at the answer because this just feels weird, asking about phi of n with respect to an infinite group. For each positive integer n. What is an element of order 2 in C star? Something squared that equals 1? What is 1 plus... Well, no. Okay, negative I. Oh. Hey, Cosmolano. Hey, and hey, Ben, and good night. Hope your surfing was good, Ben. So I guess negative I is order 2, right? Because negative I times negative I is positive 1. Okay, so that's, even though it's infinite group, we can have a finite order, I guess, which I didn't think would be possible. But I guess multiplication rules are different. Awesome. Whoa. Hope you sleep well. So am I back to finding a generator for G? Or for C star? What is a Grassman number? Grassman sounds like some super lame, like, superhero. Anti-commuting number or super number? Oh, there's 2 n's, okay. Hmm. Okay, this is too complicated for me. um, what is the order of 1 plus I then? Is there a way that you could work this out? Like, you know what? I bet. Oh, I think the point is, well, no. What is the point? I ask myself that a lot. What is the point? um, what's the point this question is asking? Like, I thought I had the idea where like you can make these order n elements with purely imaginary or purely real numbers, but you really can't, as far as I can tell. Those are just going to be infinite order. So if you had like, what's an element of order 3? Well, I guess -1? No. Just I. I times I is -1. No. One is order 1. I is order 4. -I is order 2, and -1 is order 2. So what's your order 3 complex number? That seems like it's an important thing to figure out. Do we have something that would help us with this? Is there something that's better than guessing and checking here? Sorry, I'm fidgeting with my mouse right now. Actually, you probably can't even see when I right click anyway. Okay, cool. I'm like fidgeting with my mouse and I keep on right clicking by accident. Thankfully, you can't even see the menu anyway, so I don't have to talk about it, but I did. So here we are. Cool. I don't see any of these theorems as helping us either. Huh. The order 3 thing is probably just gonna be something random, right? Let's just try 1 minus I. Multiplying that with itself a few times, just seeing where that goes. So I feel like it can't be something that complicated for an order 3. I guess it could be like something fractional that I might not guess. Minus I times minus I. Why is that weird to me? Is that still minus 1? Or is that plus 1? Because... Wait, this is... Could I say that's minus 1 times minus... Do I not know how complex... I don't know how complex numbers work. I feel like... I could get positive 1 or negative 1 from that, depending on if I can mute things. I'm gonna Google something really stupid right now. I thought it's supposed to be positive 1, but I feel like I can show it's negative 1. Minus I. Negative 1. Wait, and how do you... Oh, wait, no. I think I'm getting mixed up. Because I said negative I to the 4th is 1, didn't I before? No. Negative I squared is positive 1. Is that even true? It should be negative I to the 4th. Negative I times negative I is negative 1. Negative 1 times negative I is positive I. Positive I times negative I is 1. I don't know what I said it was before, but I hope I said the right thing. Okay, and so that means for... this thing right here, that is a minus 1 there, not a plus 1. So you get minus 2i. But this isn't really going to become anything special. It's going to become random numbers like this thing up here. Let's try one more, 1 minus I, just in case I'm missing something. Could see this one maybe working out. So I'm just gaslighting myself. No, this one will work out, I swear. Positive 2 I squared becomes negative 2. Ah, no. It's negative 4. Okay, never mind. I think you need fractions to get an order 3 thing, is the conclusion I'm coming from. Or 2. Maybe not even then, I don't know. Maybe 1 part whole number, 1 part fraction. I'm still kind of lost on how you, would go about doing this. A lot harder than GCSE. Yeah, is that L labs or an I? Maybe that's like Yabs? I don't know, I'm probably mispronouncing that horribly, but yeah, this is it's an L? Okay. Either way, welcome in. This is abstract algebra, which it's like undergraduate math student level, I would say. It's something I've been studying to fill in the time while there aren't questions from chat, pretty much. Yeah. I'm kind of struggling with this one on screen, though. I might need to take a peek at the answer or something, because I'm, a little stuck on it. I might be able to figure it out, critical, but I don't want to be very confident in it. The only way I see doing chemistry frequently is gold. Well, yeah, so phi of 2 is 1. In the element of order 2, what did I say that was? Negative 1. And for order 4, it's I and minus I. But like I was trying to come up with what the element of order 3 is, and I can't. And I think the main point of the question is to find a generator for C star, because that's how this would definitely be true. Oh yeah, no, that's my issue, Fembox fan. Like, to me, the obvious candidates are 1 plus I and 1 minus I, but they just seem to be kind of random. Like, I would guess infinite order before anything else. But it's not like 1, negative 1 I or minus I, so I assume it's some combination of real and imaginary number that I can't quite figure out. They are infinite order, okay. But there should be one element of order 3. No, sorry, 2, because 1 and 2 are relatively prime to 3. Yeah, I've been trying to figure out this entire time what, or for most of this time, what the order 3 element would be, and I don't really know. Like my next guess is maybe like 1 plus a half I or something. Satisfy. Oh. Oh. LabsCon, you have to revise for physics GCSE tomorrow. Oh wow. Well, good luck with that. Thanks for popping in. Good luck. Oh, that's the roots of unity thing. X plus 1 squared equals 0, x plus 1 to the 4th equals 0. Okay. Or, no, I'm sorry, not x plus 1 squared, but x squared plus 1 equals 0. Huh. Is that the way they intend you to do this? Like, I want to investigate this, but... So what you're saying is that, like, order 2 comes from x squared plus 1 equals 0, because x is plus or minus I. Is that right? No, sorry. This is order 4. Order 2 is x squared minus 1 equals 0. Well, order 1 or 2, I guess. Because 1 is order 1. If that's a special case, though, I'm willing to, like, deal with it. What would, like, an order 3 be, then? Because I thought it would just be the degree of your x. Am I rating these wrong? Because I guess what we're really interested in is x to the n equals 1. Where x is a complex number that's not 0. Or minus 1, but I'm just going to separate it out. X cubed. R has to be 1. E to the I, 3i theta is 1. Is that how you did this effort? Why doesn't this make sense to me right now? I don't know why someone else will be able to tell me that. Hey, Archive, should you take linear algebra and differential equations or Calc 3 first? Take linear algebra and differential equations or Calc 3 first. The way they were taught at my school, they were all pretty separate. It didn't really matter which one you take first. If you're gonna do one of them first, linear algebra is probably the best to do first if you're really like worried about it, because differential equation and Calc 3 will be a little more interesting. Like there'll be some more connections with diffeeqs and Calc 3 if you know linear algebra. But at least from my experience as a university student, it didn't matter. I don't think they were prereqs for any of the others. It's one course at your school, linear algebra and differential equations. Interesting. I definitely combined them after a certain point in my coursework, but not at first. Like I started with taking each of the classes separately. I would say, especially in that case, there probably isn't that much gonna give me that much of a difference, in my opinion. Calc 3 might still be more interesting if you know linear algebra, but it's mostly going to be kept separate. I would think, at least, or even taking them like simultaneously would be good enough to like see the ways that Calc 3 relies on linear algebra in some ways. But I guess I personally wouldn't be too worried about the ordering of those classes. No worries. So wait, this means 3 theta is equal to 2k pi? Oh, well, it's going to be some root 2 plus root 2i business, isn't it? Or maybe like root 3 over 2. Okay. And is it 2k pi? I guess it would be for k equals 0, 1, 2, I think is the rule. So theta equals 2/3 k pi. So if k equals 0, you get theta equals 0, and you get your real answer of 1, which we're not too interested in. If k equals 1, we get e to the I times 2/3 pi. 2 pi over 3 is cosine of 2 pi over 3 is 1/2 plus root 3 over 2i for sine. e to the I 4/3 pi. Minus a half minus root 3 over 2i, and actually I messed up the sign there. That's a minus. So are these my order 3 complex numbers? Let's try it out. Let's get the square first. These are conjugates? One half minus root 3 over 4i plus root 3 over 4i plus what? I think I'm messing my fraction math, aren't I? That should be 1/4. And that's 1. Dude, look at that. Okay. Okay, sorry. I was caught up in the math. Let me catch up. Corrupt. Hey, you're very appreciative of the bringing of the family of mathematics into this world. Or I think it's a typo, unless there's some kind of like joke there that I'm missing, but fair enough. Yeah. 0 plus 1 is hard left because you're first. Nice. Sorry, give me 1 second. Oh God. Did I tilt the camera? No, it's good enough for me. Math is the most fun subject in school. Yeah. So let me check my math on that last one. It's gooder than English. Hard agree. 1, okay, good. And my other root of unity, same thing with a minus. I guess 3rd root of unity, right? Okay. Okay, so that's the idea. So, oh, it's the point here that C star is not cyclic, but it can still have exactly phi of n elements of order n. That implication only goes one way, I guess. So I assume that it needs to actually prove that the equation like x to the n equals 1 has n minus 1 many solutions, or you know, what the relatively prime number of solutions. Ooh, maybe we do need to prove something with that. Um, I should give Penbox a save because that was a good suggestion. Oh, Archive, this is, let me show you. So I dual stream to Twitch and YouTube, and over on Twitch, there's a Twitch streamer named Pen Center, who's in this list of streamers that's about to pop up. And Pen Center is doing a reading group on abstract algebra. So it's just like a for fun thing. I'm on page 111. But I've been studying out of this textbook here, while there aren't questions from chat. And yeah, it's been like a reading group on abstract algebra that Penn Center's been running that I've been reading along with to help like fill time and still do like math things while we wait to see if there's someone in chat who needs help. The formula for this shape? I don't know. Is there a formula? So there's a few like different shapes in here. But they chose a very like symmetric shape. Like you'd say, you could talk about like the rotational symmetries and the we call like the flip symmetries. There's probably a better word for that. I mean, it looks a little bit like one of those flower-looking shapes you can get from a polar curve. Somewhere in the Mandelbrot. Oh, I mean, I wouldn't know anything about that, to be honest. Polar curves are hell to graph. Yeah, they are super annoying. I personally, I really like polar coordinates. I think they're fun. But yeah, they can be a pain to graph. The intuition is pretty hard, and I don't really have it for myself, to be honest. I don't know, corrupt. I don't know what the Mandelbrot set is, I guess. Do they show up in classes higher than Calc 2? Well, yes and no. I would say you don't really get, after Calc 2, you don't really get quizzed on those really annoying polar curves. Where would Paul's notes go over it? I don't remember. Okay, like you don't get made to graph super annoying things like r equals 5 plus 3 sine squared theta or something. I don't know what this would oh, I guess that's a pill shape. But you don't have to graph annoying things like this. Which is a relief, or I forget how you even make like the flower looking things, but you do have to get used to changes of variables though. And in like Calc 3 especially, you're gonna learn that instead of Cartesian coordinates like x, y, and z, there's cylindrical coordinates, spherical coordinates, and you're allowed to invent your own type of coordinates if you want, like arbitrarily. But you don't have to, like, they don't ask you to graph really annoying things with those. You do have to do calculus with them, but you don't have to necessarily be able to visualize it. I don't know if triangular or hexagonal coordinates would be a thing, but I mean, I guess it's I just been talking about like changes of variables in general, I guess. You hate them with a passion? Uh, yeah, they get introduced in a really annoying way, but they will make some really difficult problems like a lot easier. But yeah, the first time you encounter them, it's they introduce it in a very painful way. Unfortunately, alphabetical coordinates. Don does coordinates. um, so, like, what are we going to say as a proof here? If we have, for any given n, this isn't going to match with phi of n. The way that I'm thinking. So I'm thinking like, x to the n equals 1 has n many solutions. But for the sake of phi of n, and like in this algebra context, we're throwing out ones that we've seen before. So 1 is always a solution to x to the n equals 1, but we don't care about it for n greater than 1. And if we have x to the fourth, -1 is a solution to that, but we don't care because we encountered it with x squared equals 1. I think that's the idea. I don't know how you would write this out. But you only get phi of n many new solutions for each n. Okay. I'm going to take a peek at the back book for this one too, because I want to see how they actually say it. I feel like I've found the idea. Oh, dang it. What? Yeah, no, I'm annoyed because they apparently already did this work for us. There can be at most n such elements. I feel like they're skipping over the thing that I said with... I guess they get to skip over because they are finding... cyclic subgroups in C star. I don't get how this is a proof, though. I guess it is a proof. But it's a cyclic group of order n, and every member of this group satisfies x to the n minus 1 equals 0. Since every element of order n satisfies x to the n minus 1 equals 0, and there can be at most n such elements, all complex numbers of order n are in H. Okay. I don't get how C star gets to use... Like, H is a cyclic group, but C star isn't cyclic. I'm guessing maybe I shouldn't be stuck on cyclic things. All complex numbers of order n are in H, but H may also contain orders less than n, coincidentally. Well, it has to, at least for the identity, if nothing else. I feel like the piece that I'm missing I think I figured it out. Okay, so this H cyclic subgroup that is order n has exactly phi of n elements of order n because it's cyclic. And this is saying there can't be any other complex number of order n that is not an H by construction. So by those two things put together, C star has phi of n elements of order. Okay. Ugh. And I can see that parallel, I guess, with the dihedral group one now, I guess. What a pain. How many more of these do we have? Oh god, we're like a little bit past halfway, to be honest. All right, 51 to 53. Let P be a prime. If a group has more than P minus 1 elements of order P, why can't the group be cyclic? More than P minus 1 elements of order. Wait, P be a prime. This is... Isn't it not following the... Well... Okay, the Euler phi function, the theorem we have with that goes the wrong way, right? Where if a group is cyclic, it has phi of d elements of order d. Here, we're given it has at least p many elements of order p, which certainly cannot be the result of phi of p. But we can't directly use that theorem because we have the then but not the if. Like we had the wrong side of the implication, I guess. Well, actually, what I said isn't even true because we don't know that it's cyclic. It could be a multiple of p. Actually, well, I wasn't. Wait, what? I need to see the question again. More than p minus 1 elements of order p, why can't the group be cyclic? Actually, do I have the answer? If it is cyclic, then it has phi of p many elements of order p. And phi of p is less than p. Is that the, like, maybe I'm overthinking it. I'm checking the answer, gang, so I do not feel confident at all today, I guess. I didn't consider infinite cyclic groups. Okay, but I think I basically had the idea. So it's 51 through 53, so let's look at 52. Suppose G is a cyclic group and that 6 divides the order of G. Hey, Nicholas, man. To order an element G of a finite group G divides the order of a group. Yeah. 6 does G have? Um... 6 divides the order. I mean, isn't it just phi of 6 still? Like, we don't care that 6 divides G, do we? If 6 divides the order of G, I thought we don't care about the order of G. We can just say that we know it's a finite cyclic group. So the elements of order 6. What? 1? 5. So there's 2 elements of order 6. And for 8... Oh, thanks, yeah. Welcome in, by the way. Elements of order 8. 1, 5, 7, 3. If A has one element of order 8, or if A is one element of order 8, let's see other elements of order 8. Shoot, there's a trick with this. It's like it's gonna be like the order of G divided by something. You like the group theory exercises that you can't understand most of them? I mean, that's fair. I've been struggling. I've been struggling with this chapter. And in case you're not aware, there's a whole like whenever I see new faces, I like to shout out. There's a whole like community math streamers out there, and let me get Hobos in there too. This is from Penn Center, who's in that list. He's doing a reading group on abstract algebra, and I've been kind of reading along. I think he's a chapter ahead of me by now, but I'm kind of just going at my pace in the downtime while I wait to see if there's someone in chat with a question. Oh, I can show the cover. So yeah, Contemporary Abstract Algebra by Galleon. I mean, if you're learning more and reading along with the group, I would hop in Penn Center's Discord and ask to be added to the reading group. Of course, you don't have to do anything you don't want to do, but just if you're interested in like participating more actively. And Penn Center himself does like reading group streams once or twice a week, I think, on this. So it's more like a filler thing for me, but he like has dedicated streams for it. Oh, awesome! Yeah. So yeah, I hop into Penn Center's Discord, that last link there, and then like throw his channel especially a follow. I mean, I recommend you follow all of them, but you don't have to do that if you don't want. You're also welcome to hang out with me when I do it. I just kind of do it at random times whenever I feel like it, so it can be hard to catch me doing it. But yeah, I can, or if you do hop on his Discord, just like put a message in like the general chat asking to be added to the reading group. Or if you don't feel comfortable, I can ask that you be added as well. Yeah, there's a PDF of this book posted in there too, so you'll be able to have your own like copy to look at. I'm on chapter 4. I believe they moved on to chapter 5 by now, though. Started doing some chapter 5 yesterday. Interesting. I feel like I heard Penn Center complaining about it. About the stuff they're going over and that one being annoying. Okay, it does not depend on the order of the group. So is that a red herring? It's on Sunday night and wait, there's 4 numbers relative to prime date? 1, 3, 5. I flipped off 3 the last time. Oops. Oh yeah, but what I need is if you have an element of one order, what are the elements of the other orders? They had an example like that. The order of A be n. Well, It's not this exactly, is it? What was the example they did with U? They did an example like U50 or something. I think that's the same thing that we need here. Probably passed it, didn't I? Oh, so wait, it's the things that are relatively prime to 8. That probably should have been a bit more obvious to me. So if A is one of them, then A cubed is another. A to the 5th is another, A to the 7th is the last one. I think is the idea. All right, let's take a look at 53. It's all the elements of Z40 that have order 10. 10, 20, 30? No. 4. And I think all of its multiples. Maybe not all of its multiples. Should check that, right? Everything that has a GCD of 4 with 40, every number like that, right? So 8 is actually bad. That's order 5 because its GCD is 8. Okay, that's the trick. So I would say 4, and we're maybe adding 8 each time, so 12. 16 is bad. No, 20 is bad. Um, 4, 12, 24. Are you good or bad? Bad, because you have a GCD of A's. 28 is good. 32 is bad. 36, good? We have 4 elements. Oh, shoot. 40 divided by 10. So we'd have, yeah, we have 4 elements of order 10. That kind of makes sense with Z40, right? We probably have a theorem that says that. I feel like that they did one that said the exact thing specifically for Z sub n. I don't see it though. It's for a generator of Z sub n. I don't know. But I feel pretty confident that we have 4 things of order 10. Oh, is it this? No, I don't think so. Set n over k is the unique subgroup. No, I think it's you have to do it the way that I did it. Just finding the GCD part manually, I guess. Because I don't see a better way to do it. Oh yeah, and phi of 10 is 4. Okay, okay. Yeah. So I think I did it the intended way. I assume I did at least. There wasn't like a more of a shortcut way. Let the order of XP40 lists all elements of the group generated by X that have order 40. The order of XP40, isn't that just 1? Isn't that a generator? Or is this X something completely... Oh, no. X is not a member of Z40. X is a member of an arbitrary group, I think. And that's going to be... I think the same idea, though. X to the 4. X to the 12, X to the 28, X to the 36. It's an odd number, so let's go check that. Oh, that's the trick. I forgot. You do 1 times 4, and then you do... all the numbers that are relatively prime to 10, you multiply with 4. That's how... Okay, yeah. I did it manually, but... that's how you actually do it. Okay. Or that's like the shortcut way that I thought might exist. We get back to the reading group channel, see what else Penn Center assigned. How many more are there left? 58 to 60 is 3, 64, 68, 69, teehee. We got like 10 more. Let's take a look at 58. If G is an abelian group and contains cyclic groups of order 4 and 6. What other sizes of cyclic subgroups must G contain? Oh god. I feel like 2 and 3 are pretty big possibilities, but those are the factors of 4 and 6. I feel like my brain is starting to shut down though. I was just looking at 58 Phobos. I don't know. I should really have a better way to like emphasize which one I'm actually working on. Might say to say 2 and 3 because they're factors of 4 and 6, but I don't really know. I tend to just call it because I feel like I'm having a hard time thinking now. Actually, oh, they're LCM, right? Been out of it all day too. Yeah, I don't know. It's just like one of those things. Because 4 and 6 have to both divide this thing, I think. I don't know where the abelian part comes in. But doesn't it have to have a subgroup? If there's a cyclic subgroup, of 4 and 6, one doesn't divide the other. I mean, or even then, their LCM has to be another cyclic subgroup, I think. Can commute, you can combine powers in a trivial way, is why it's abelian. I feel like the thing that I'm thinking of doesn't even rely on that. Maybe there's more that you can say if it is abelian. What am I thinking? Like, maybe it's gonna be the fundamental theorem. For each positive, yeah, this is what I want. For each positive divisor k of n, the group A has exactly one subgroup of order k, namely a to the n over k. So if 4 and 6 are subgroups, then I think 4 times 6 is our n, which is 24. And so it must have a subgroup for each divisor of 24, right? So 1, 2, 3, 4, 6, 8, 12, and 24. Oh, else. Ooh. You're right. LCM. You're right. I was saying LCM before and I forgot. LCM makes way more sense. Because it could have 24, but it doesn't have to have 24. The H divisor of 12. And I guess the generalization is that if an abelian group, well, I mean, that still doesn't rely on the abelian part. Can we say even more than this? A equals A, B equals B. Satisfy orders of 4 and 6 with the order of A, B. Oh, there's that theorem that says if the elements commute, the order of AB is the order of A times the order of B. But that seems weird then. It's an even number as well. So I don't have the answer in the back of the book to cheat with. I'm wondering if we could just put like an A to the or like a subgroup order 10 or something. If it's abelian. I don't know how exactly you do that though. So I assume it's still like 12 is the only one it has to have, and doesn't have to have 24. So if it's abelian, I assume that will let you do more things, like just finding an A to the 10 or something. I don't actually know though. Not A to the 10, just in order 10. I'm not sure though. I think I'm just gonna leave it in maybe Google or check Penn Center's VOD or something there. I think I'm gonna call things, yeah, because my brain is moving like half a mile an hour right now. From most of the stuff you did chapter quite a while ago. That's fair. All right, I'm gonna cut the YouTube stream off here. So if you're on YouTube, I appreciate you, but I'll see you around.